Hey everyone, I'm Follygon, and in this video we'll be taking a second look at my Voltaic Axe from Monster Hunter. If you haven't seen the previous video where I actually make this, you can click the link in the top right of this video to go check that out. This time around we're going to slow things down and take a look at some of the techniques that I use to make objects 3D printable. Specifically, let's begin by looking at drafting. So we're talking about overhanging parts and undercuts pretty much. If we take a look at this scaled piece that's on the side of my mesh here, you can see that it is already drafted back onto the axe. What's nice about these parts is that we have subdivision levels on them, which give us these vertices that we can manipulate at a lower level and make adjustments pretty easily. And that's how I was able to draft these back onto our axe here. But unfortunately, this is not always the case. If we take a look at this piece here, it is a duplicate of our scaled pattern up here, but I essentially removed all the drafting from it that I had done previously. I also was super nice here and dynameshed all the parts together. So just to give us like a worst case scenario, you can see that these are all connected as one mesh. How would you go ahead and draft this back onto your mesh? Because if we look here, if we're trying to print this, it's not really gonna work. One, it's not touching our main portion of our 3D print at all, so that's just not gonna work. We can't have floating parts. That doesn't make really any sense in reality. And we could attempt to slide it back on here, but that looks a little good, but we still got some gaps going on here in the back, and maybe you could adjust them with your move brush, but then we're getting some weird warps in the geometry and some deformations that we don't exactly want to happen. So let's instead grab our transpose tool, pull out a line horizontally, and you can hold the shift key to kind of snap that in the direction you want to go. And what I'm going to do is turn on backface masking. Backface masking is located under your brush palette. Down here you can see auto masking and backface mask. If you turn that on for your transpose tool, when we go ahead to move this, you're going to see some weird stuff happening and it might be a little confusing. So if we're using our transpose tool and I push here to the left, if anything that is back facing here will not be affected by that move. Similarly, if we turn to the side here, anything that is past this edge here will not be affected because it is facing the back side of the mesh. So we'll go ahead and undo that. And we'll turn to the side here and just go ahead and draft that back into our mesh. We're getting some weird little artifacts. Those kind of things are to be expected from using a technique like this, but it's not the end of the world. We can go ahead and re-dynamesh this piece real quick. And then from there, I'm just going to go ahead and slice it off just to see kind of what we can get there. And I'll turn on double just so I can see the inside of my mesh there as well. So at this point we need to do some kind of upkeep, some cleanup to maybe get this to work a little bit better. Maybe I'll take an H polish brush to my edges as well as some smooth to kind of grind that down and get it looking a lot cleaner. So this is like the worst case scenario of what could happen if you're trying to draft something back onto your mesh, and I've definitely been in these kind of situations before. So you could also try your planer brush if you want to work on something like that. Try and smooth that down a little bit. Your trim dynamic brush is also really nice for filling in cracks and crevices and trying to fix a lot of that stuff. You could also Z-remesh this or re-topo it and project details back onto it if you needed to. Play around with those different things. But again, in the end, your best kind of solution is just to have those nice subdivision levels with the lowest level subdiv that you can modify all the verts or edges or faces that you need just kind of at that low level. Next here, I want to point out some thin parts and how you can come up with some creative solutions for fixing these. So if you're not used to 3D printing, if you've only ever worked digitally, you've probably never been in a mindset where you thought, hey, can this exist in reality? At least to the point of where, could I physically print this? So this axe currently, I believe, is about 7 inches tall. We're looking at, well, close to 7.2 inches. So the diameter of one of these horns is probably pretty small. We're looking at 0.13 of an inch there and 0.05, and it's getting really thin as we get down here, and it's okay to have some taper like that. That's totally okay. But what's not okay is having these exist separately. I mean, none of this is ever going to print. You're probably going to have a lot of failures there. So I had the creative solution of using this fin shape and adjusting it in such a way so that I could just lay the horns up against this fin. So the horn, if you take a look here, all the horns are slightly tilted in towards there, and then if I turn on my transparency, you can kind of see how those are laid up against that fin, all the way up to its thinnest part. So even with this technique that I'm using here, we might get some failures up here on the tip, just because this area is so very thin. So that was kind of the design or creative solution that I came up with. I didn't really have to adjust the shape of the fin too much. I was able to keep it pretty close to the concept and still make it a lot safer for printing. The last thing I'll show you guys here is breakouts, or what is more commonly known as keying. If you don't know what that is, think of it like puzzle piecing the parts of your 3D model together. Much like a key fits only in the lock that it was made for, we'll be doing a similar thing here. So looking at this axe, if I was looking at it and I said, yes, it's about 7.2 inches tall, and that's how tall I want it to be, but my printer is only a 6-inch tall bed, how am I gonna do this? Well, obviously we wouldn't just print this vertically like this. Some people might try to print it horizontally as a single piece, but that's where breaking out your model and keying it come into play. So using my slice curve brush, I could, yes, just easily cut this in half and have a nice good, let's go ahead and split that, close holes, a nice flat right there to print on. But if we're printing halfway down here, halfway up, let's look at this. So think of it as we're printing from this part up. Well, we're obviously going to have to chop off at least part of this axe head because it goes down below our break line. And we're going to have a lot of support being generated up under here that's going to mess with a lot of our shapes. You want to have support in places that are going to be really easy to clean up. Another problem that we're going to have here slicing the mesh at this exact location is that it's going to be pretty difficult to retain this texture throughout this cut. So what I would instead like to do, instead of slicing it in the middle of the mesh, is looking at this part right here. This is a really nice flat down here, and I would like to print off the bottom of here and then go up from there. Maybe chop off the head of the axe or let it insert into the axe head. I'll probably keep the rest of this as a single piece. Maybe breaking off the diamond, I'm not sure if I will or not. Next, all we're left with are the handle and the little covering that goes over your hand here. Not sure what that's called, it's some kind of guard. But what I would like to do is do a Boolean operation to subtract that from the main portion of the axe there. And then I'll do the same thing with the handle, where I can do a little cylinder up into there, which is essentially the puzzle piecing part that I'm talking about. So you'll see that all here in a sec. So I like to begin by thinking about what parts will actually be merged together and start kind of putting those together and thinking about dynameshing them or what I'm gonna do with them. So I know for sure that all the parts of the head of the axe will be together, so I'm just gonna go ahead and combine all of those. What's good about merging all these parts and pieces together is that I can look at them individually and kind of think about how support is going to be generated on them. For instance, if I'm looking at this part here, it's going to have a little bit of support under it. So a good rule of thumb is anything that is over an angle of 45 degrees is going to need support on it. So looking at this diamond shape here, this will most likely not need support under it because it is over an angle of 45 degrees and will not need the generation of support, at least under here. As we get out here to the edges, I would assume that it is going to possibly need some support, but again, looking at the angle here, we can see that it will most likely not need it. Once we throw this into our slicer though, we're going to get a pretty good representation really quick of what our support's going to look like, because that'll be all computed mathematically. I'm a little worried about this area here on the back of the fin generating a ton of support, which is most likely going to be unavoidable unless we just change the angle of the print here. Let's go ahead and leave this for now. I have a feeling that this is going to be pretty good for printing, minus maybe the horns here generating some support up under those, which could be a little bit rough to clean up as we go here. Keep in mind that you typically want to print vertically, and what I mean is not like this piece is tallest this way, so print it that way, always print it that way. But you want to think of printing as your resolution is layer by layer, right? So as you go higher, you have more layers, and you want to get the most amount of layers out of your print, the most amount of resolution. So if we were to lay this down, of course it would use the same amount of material, but it would have less verticals. It would have less layers, less striations. So those layers are going to be a lot more visible if we print it laying flat, whereas if we printed it tall, all the layers would print upward, and we would have a lot more to go with, a lot more resolution. For the head of the axe, I'm thinking if I would like to just create a flat slice here, a flat slice of the shape could just line up with each other, but then that would create a little seam, so I think it would be cool to show you how we could key these two pieces together. We can go ahead and subtract part of this axe head from the rest of this mesh, and it will act as a key. Another thing we're going to have to think about is how we're going to print the head of this axe and the orientation at which that will take place. If possible, we might print it in this direction, just so that all the support generated is up underneath of it and in the least visible place. So if you do have to put support on something, keep in mind that you want to keep it hidden or keep it as out of sight as possible. Here comes the part where I actually key the cube shape here from the handle, or from the actual stand of the axe. I'm not exactly sure what you would call that. But what I'm going to do is I'm going to subtract it from the axe. And the problem is that if I just subtract it, that keyed piece, that axe head, will not fit or slide in there very well. And the reason that is because it's the exact same size as the little piece here. And that might sound like it would work, but in reality there's friction and there's also some margin of error, we'll call it, when you're printing anything. So unfortunately that's not going to fit in there too well. So what we need to do is we need to add some clearance. And what clearance is going to do is it's going to give us a little bit of a gap there that we can work with. So it gives us that margin of error that we need to actually be able to slide that in there. So this is the essential idea for keying your model and getting it to kind of work with your mesh and be able to work in there. So as we're zoomed in here, this might seem like an extremely large gap that you got going on here, but just think in real world scale here for a minute. If I measure that, that's really 0.01 of an inch. I mean, if we zoom out here, it's a pretty small gap. So that's really not that much clearance, but we're gonna go ahead and try that and see how it works with a print. I'm giving away this model for free, so I'll also be providing the original base mesh, the Z tool, and the broken out completed model. So if you decide that you don't like my breakout, or if you want to use parts and pieces of it, you can do that. Or if you want to just completely redo it, you can also play with it and do whatever you need. Right now I'm just softening the edge on this piece because I don't want it to be so sharp that when I dynamesh it, it starts acting really weird with the geometry and then it destroys part of that mesh. Here I'm doing another Boolean subtraction, so I'm just removing that lower hand piece, that guard, from the axe, and you'll see here that it'll just piece right on there nice and perfectly. From there, I'm actually going to do something really cool you'll see here in a second. So from here we have our piece subtracted, And what's really nice about this shape that's left from our Boolean subtraction using Dynamesh is that we can select this piece, and you want to make sure that it's the only part visible, and we're just going to run a group loops on it. From there I'm going to clear my mask and grab my transpose move tool and control click on the face. And this will select only that front face. We want to make sure that we only grab this front face so that we have this nice smooth transition in the geometry there. And I'm just gonna pull that out a little bit here using my scale tool, bring that in, and we'll bring it in a little bit more. And then from here I'll grab my slice curve and try about right there. And let's see what that looks like inside our mesh. Let's go ahead and remove a lot more actually. So we just want a little bit of registration in there, and that looks pretty good. So let me seclude some of this geometry, and then we can delete that and close holes on that. So from here I would like to go ahead and Dynamesh this piece again and subtract it now from here so that we can key that part. So for our handle, because we have our subdivision levels, I'm able to kind of create a nice little pulled up shape into our axe here, and then I can Boolean that, subtract it, and then have a nice little plug-in piece there. So let's go ahead and do that real quick. Alright, so there we go. We got our 4 parts. We got our axe here, we got the head of our axe, which plugs in, and then we have our guard handle here, which has a nice little subtraction, can plug right into the axe there. And finally our handle, which plugs into the bottom of our axe. Alright, so hopefully that was helpful so you can see how you can do a breakout or a keying of your own 3D model for your weapon, or whatever you're going to be 3D printing here soon. Hopefully that helps, hopefully you learned something, and maybe you can play with this model, break out your own, or try and follow along and practice that way. Alright, so that's going to be it for this video, guys. If you don't know, new videos are uploaded every Monday, Wednesday, and Friday. Be on the lookout for those, or go ahead and click that subscribe button if you have not done that yet. Hope you learned something here, maybe got a little inspired, and I'll see you next time. Thanks for watching, guys.